Good morning, good afternoon, or good evening, depending on where you're joining us from today. My name is Chuck Tatham. I am the Chief Marketing Officer here at DENSIFY, and I'm pleased to be hosting our session today with Dinesh Ravindran, a cloud architect at DENSIFY, and along with him is Pegah Garusi, one of our solution architects. And the combination of content today will be, I think, very practical and interesting because it is not only a little bit on some of the theories around what we call continuous cost optimization and its relationship to DevOps pipelines. We're going to tie it down into some actual real life customer examples, which I think people always like to see in these types of sessions. Our agenda is pretty simple. I'm going to talk a little bit about the case for continuous cost optimization, give you a sense for what's driving the need to look at cost optimization in a continuous fashion. We'll then hand over to Dinesh to talk about continuous cost optimization within a DevOps pipeline. He's going to share some key components, some reference diagrams or reference architectures, and actually give you a demonstration of this happening in real life. It's pretty cool. Pegah will then talk about two distinct customer case studies to make what Dinesh was talking about much more real in the context of real infrastructure. And then for those that stay to the end, we will be doing a drawing for a very excellent giveaway, a Nintendo Switch, which is timing-wise fantastic, great under the tree as a gift if you choose to give it away, and a Visa gift card as well, just to keep things interesting. You can enter questions through the console at any point during the presentation. If a question comes to mind, log it, don't forget it, and we'll try to cover those at the end, provided we have time. So in the interest of time, let's get at the content. So the world of infrastructure cost control or cost optimization is very, very different than it used to be. It used to be that you would procure servers, you would negotiate centrally for a great discount, you'd buy those from your favorite hardware provider. Much easier for larger enterprises to keep control of it. In today's cloud and increasingly container-driven infrastructure, it is vastly different. We now have, in many organizations, potentially hundreds of people as part of a development process and provisioning process, making selections for resources, subscribing to them, albeit in a maybe micro fashion, constantly. And this is just fundamentally different. And extremely difficult when organizations, finance organizations, increasingly FinOps organizations are asked to try to control this stuff, what is largely on the fly. And so our content today is all about how there are better ways. Surprisingly, not surprisingly, you can use software to help you with this challenge. And the challenges are really increasing because of a number of elements, and I will cover these elements. One is, and it's the topic today, the DevOps process is driving things faster and faster in organizations. It's a wonderful thing to get this functionality fast, but it's creating this challenge at speed. The second is that the people, the individuals that are making decisions, those micro purchases, are really primarily interested in the agility, the speed, and the performance of the infrastructure. Cost is not their primary concern, nor should it necessarily be. The rise of things like Terraform, CloudFormation, infrastructure as code, the way infrastructure is now provisioned, is creating a dynamic where people are embedding their resource wishes into code. And this is an actual little snippet of code on the left there saying, give me an M4 large. Every time that thing provisions as code, that resource is perpetuated. And then the last is that once stuff is deployed, And once app owners are getting their functionality, it's really hard to go back and get them to agree to allow you to change infrastructure. So in our experiences, and we'll wrap this right through to actually showing you real customers, it's very difficult to succeed in a manual form because all of these trends create not only in most cases a lot of waste, but also a lot of resistance to optimization after the fact. So to win, you really need to look at the total challenge. A lot of organizations look at cost savings in the cloud by changing the way they buy, making bigger commitments, getting discounts based on reservations or savings plans, those sorts of things, RIs. It's really only part of the picture. The big thing, the big element of cost is really the consumption side. And if you have all those dynamics on the prior slide happening, and you don't deal with this bottom of the pyramid and optimize at the instance or container level, it's really hard to drive the optimal cost case for cloud and containers. And we see over and over again huge wasted spend as part of this infrastructure supply chain. So that's really what we're talking about today. In order to win at this, you have to be able to do the following things. You have to make sure that stuff runs properly. That's job one. Nobody wants to mess with things and make them run poorly. But you need to be able to size your instances for cost efficiency at the same time. You then, and only then, do you make sure that you're purchasing them properly. If you're getting a great deal on the wrong quantity, that's kind of dysfunctional. And then you have to be able to get your costs distributed to the places they need to go. So this is what good looks like. To achieve this, in our view, you need three key capabilities. You need to be precise, which means that that the answers you provide the organization can be trusted and therefore then allowed. You need to be able to agree in a unified way on policy. The policy and associated transparency allows the organization to say, we all are looking at the same information, we've all agreed to the policy, therefore we should allow these changes to happen. And then the third piece is that in most organizations, there is a significant investment in BI, collaboration, ITSM and ticketing, the DevOps tool chains, those sorts of things. A solution like Densify can't compete with those things. And so the way we approach what we do is to focus purely on driving the optimal resourcing answers such that we can feed those answers to the systems that need them in order to make the infrastructure better every day. We're different in that we don't focus necessarily on the bill, we focus on the demand patterns and the deep detail of the way applications are behaving. We cross them with infrastructure attributes, the performance benchmarks, the technical constraints, the cost models associated. We do ingest the billing data because it has to inform everything that we do as part of this process. Tagging is extremely important. The ability to identify and lasso certain portions of infrastructure and treat it differently at the policy level. And what the policy allows us to do is specify what is fit for purpose for any given class of workload. And then what comes out of Densify is a continuous heartbeat of optimization in the areas of fixing the instance level, the placement level and overcommit, migratory changes that you might be making or considering, and of course the finance side of it. And what happens within these answers is that level of precision that allows you to take that output and get it into the hands of the individuals that will approve an optimization, because without approval, without trust, it doesn't happen. And then the last mile is getting it applied in an automated fashion back to the infrastructure, in an automated and controlled fashion. So when Densify does what it does, it is primarily focusing first on, can we make it perform better? Can we make it healthier? And then secondarily, can we do it cheaper? So if you look at an instance level optimization, we will deal with an upsize, modernize, or change family if it's going to make something perform better first. Tick the box, get the trust in the organization, and only then can we do it cheaper. And of course, that would cascade into not only cloud instances or IaaS, but also scale groups, now containers, which have a whole different set of complexities, and of course, the purchasing component. So we're not just running around saying, oh, there's a suggestion here for a save here or a save there. We're giving you a precise answer that you can actually go and apply back to infrastructure. Now that application of it back to the infrastructure is all about these answers, this precision now fitting into and playing within the componentry that an organization already has an investment in, be it feeding more data to Densify to inform our analytics, getting our answers out to, let's say, BI and reporting, but also into a CI/CD process as part of a CI/CD process or an infrastructure as code framework, which is where we're focusing today, as part of making this a continuous feed of optimization into both the delivery, initial delivery of functionality or applications into an environment, but then also keeping things healthy over time. So that's the Densify high-level overview and the case for continuous optimization. I'm going to make Dinesh the presenter now, and he's going to continue. Make presenter. There we go. Over to you, Dinesh.
Thank you, Chuck. So I'm just going to share my screen. It should be sharing now, and I'll go ahead and start. So I'm going to avoid a long, drawn-out introduction, and we're just going to jump right into the slide and the slides and demo in the interest of time. But I do want to say for the remainder of this webinar, or at least for this section of the webinar, we're going to be focused specifically on how do we go about embedding, call it continuous cost optimization into existing DevOps pipelines. And we look at that from a technology perspective. And towards the end, as I mentioned, we have a demo of that working in a very simple pipeline. I do want to state the value of this upcoming session this upcoming section, because if you remember what Chuck was mentioning, he was talking about cost optimization, and traditionally it has always been the case where cost optimization is about intelligent procurement of infrastructure within the cloud. And we're focused primarily on the bottom half of that triangle, which is the larger discount component, the consumption optimization. It has always presented fundamental challenges, organizational challenges, and scalability challenges. So unless you have a mechanism to systemically optimize this infrastructure as part of an existing pipeline, it becomes very difficult to even go after consumption optimization. You can have the answers, but you won't be able to actually achieve it at scale in a production-like environment. So that's the purpose behind this section, to show us how to do that. So I'm going to start here with standard CI/CD pipeline. This is actually a poster that we created, and Chuck is going to provide a link to this poster towards the end, so you don't have to worry about taking any pictures. A lot of you would recognize this as a CI/CD pipeline, but it isn't your traditional form, because we have this concept, we've added on some additional steps towards the end, and we're calling those steps continuous optimization. But in all of the other aspects, it's your traditional DevOps pipeline. You have a stage here for source repository where you can commit your code, CI stages, continuous integration to build and test your code, continuous deployment to actually release, deploy, and monitor your application that's actually running in that target environment. And then we have this last component, the CO, continuous optimization. What does it mean? How does it allow us to optimize that specific application? So in order to explain that, we start here at one of what we call the very last step of the CI/CD pipeline, which is the monitor phase. You're monitoring the performance metrics of that application that's now deployed in production or in a test step environment. When we say performance metrics, we're looking at the actual hardware utilization, those low-level metrics that are either coming from the hardware directly from that provider, or we can extract that from tools that are specialized to extract that type of information. So the first observability pillar comes from this monitor stage. So if you can collect this information, you need a mechanism to actually analyze it. A lot of the customers I've engaged, they've gone in and they've manually derived these optimization recommendations. They've gone in and said, hey, based on how the hardware is being utilized, I have better allocations for my resources. That doesn't help us at scale. We really need a solution and technology that sits there and actually analyzes these applications at runtime to determine what are more optimal sizing specs. So you need to have a process here that does that, okay? Now, once you have these answers, we can head over to the last stage here that we call the collaborate stage. And we've learned this from experience. Even with these answers, it's very difficult to actually get them implemented in an actual live environment because of some of the challenges we talked about, right? One of the organizational challenges. We typically find engineers unwilling to actually go ahead and make changes to the actual infrastructure. They're worried about their application performance. They're worried about the application delivering the resulting behavior to their end clients, not about the actual hardware consumption in public cloud. So they tend to oversize. So we have this collaboration phase where we integrate to a pre-existing ITSM platform, leverage change management to go out and say, hey, this is all the empirical evidence. Can we go ahead and execute this? And we found this to really help accelerate this process. Now, once we have this approval acquired from the organization, we can integrate back into the deployment stage of that DevOps pipeline to say, hey, let me go ahead and provide you, more optimal settings for that infrastructure. Can you deploy? Now, a lot of you guys are looking at this and saying, okay, but hold on, you have a DevOps pipeline that's deploying an application. You're talking about providing infrastructure sizing specs into the deployment stage. How does that work? It's responsible for only deploying your app. And I'll get into that as we go into the slides. Now, before we get to the solution, I just want to talk quickly about what I typically see when I engage organizations on this particular topic. And we'll start with a very simple example. Okay, we have a developer or a team that wants to deploy an application into their environment. And I also want to mention at this point that the remainder of the session will be about IaaS in particular. We will have sessions on different technologies in upcoming webinars, but for today, we're focused specifically on IaaS. So we have developers, they want to deploy an application. How do they do it? They first start by deploying their infrastructure. They need to spin this thing up. They could do it manually, but if they're following best practices, they're going to go use some type of infrastructure deployment tech to get that infrastructure spun up. So they begin by creating an infrastructure template that defines that specific infrastructure with even the hardware sizing specs specified within the template itself. They'll then go and invoke that infrastructure as code deployment tech. Once invoked, it will automatically read that template, pull the sizing specs, go out into that target environment and spin up the necessary infrastructure. So you have some compute, database, whatever you have there to host that specific application. Now, once that infrastructure is there, these developers now go on and say, hey, let me go ahead and deploy my application. They build a CI/CD pipeline, goes through source, build, deployment, gets that application into that target environment. So what's the problem here? It works great. In the beginning, this application is running, everything is fine. But over time, application demand patterns actually change. The demand for the application change. It can go up, it can come down, it can stay steady. So the actual resource sizing specs must change accordingly over time. So in order to facilitate that, in order to change that sizing spec, what we find is that these users would actually go in directly into that infrastructure and make those changes directly to that, to those particular services. What's the problem with this? Well, they're going outside of the original infrastructure deployment, and this would introduce significant drift into that IAC technology to the point where it becomes unusable. So whenever I engage organizations about continuous optimization, they always tell me, well, we did use IAC, but I can't reuse that to deploy your recommendations because we're not managing it with that IAC. It's no longer valid. I would never use it because it has specs from like 5 years ago. And we've been modifying this over the last 5 years, so there's so many different changes. So that's the very first problem. That's in this disjointed process. This is a root cause. The root cause being the disjointed processes between the CI/CD pipeline and the infrastructure deployment is creating all of this drift, which makes taking recommendations more difficult. It's also difficult to trace and audit this. So if we come out with these recommendations and we have to execute these manually, first of all, there's a scalability challenge, but also where am I tracking all of these changes becomes a problem. So we need to look for a better solution. So we've tried to integrate this infrastructure deployments pipeline back into the DevOps pipeline. So how do we do that, right? So we have these developers, let's try this again. And we execute this pipeline, it goes out and it deploys that application onto the infrastructure. Now, how do we get this in? So if we're gonna practically implement infrastructure deployment as part of this pipeline, then it makes sense to look at the deployment process within your DevOps pipeline. This is where we should look at the deployment process actually somehow invoking infrastructure as code. So in this case, when we commit new code to the DevOps pipeline, the deployment process says, hey, before I go out and deploy this application onto my infrastructure, let me go ahead and check my deployment technology to see if that infrastructure is in alignment with the latest sizing specs. Or if it doesn't exist, then create it. So once that automatic execution occurs, then we'll pull the infrastructure template, which typically would be stored in some type of source repository. It would still hold the sizing specs, but it would go out and deploy those resources in public cloud. Okay. Now, as a second step, now the deployment process can go out and say, hey, let me deploy this application onto that infrastructure that you just spun up. Okay, great. Is this the whole story? No, because if a lot of you guys looking at that infrastructure, so if you're a heavy user of infrastructure as code, then you know there's a very clear best practice that I'm not following in this diagram, which is namely that if you have transient variables that are sitting inside your template, those variables should be surfaced out of the template and parameterized. Why? Because whenever they go through a change, we want to try to avoid source template modification. We don't want to go and modify the source code of the actual template. We just want it to be dynamic. It's easier to manage and it's scalable. It's also auditable and traceable. So in this case, if we attach some type of parameter repository to that infrastructure as code, instead of providing a resource size of M4 large or XYZ, whatever the case is, we can go out and say, hey, let's have a dynamic lookup to that centralized repository instead. Okay, so now if you have the organization coming out and saying, I have some new sizing specs, if I want to implement them in that target environment, I just have to implement my repository, which is source controlled and traceable and auditable. Then every new iteration of code that we're releasing in the pipeline will automatically realign my infrastructure accordingly. And if we redraw that pipeline, where does it sit now? That pipeline actually encompasses the infrastructure deployment phase. So it's part of the pipeline. So it ensures that that target infrastructure is always aligned. Now, is this still, well, before we get into is this still practical, I just wanted to explain the configuration you're seeing on the screen here. This is just my preferred approach. There's multiple ways of actually implementing this. What you're looking at here is infrastructure as code performing an independent lookup of the actual resource specs in parameter repository. There are customers that we have that implemented it slightly differently, where they actually have the CI process go out and actually perform the lookup and provide the value, provide those answers, or provide the infrastructure specs as parameters into that infrastructure. There's different ways of doing this. This is just one example that you're seeing on the screen. So that deployment process is where we modify to get this to work. Now, are there challenges with this picture that we're seeing? There's still scalability challenges that we're looking at here, right? So in this picture, cloud operations is still going out, deriving these answers manually and inputting them in manually into parameter repo. This is not going to work at scale. It may work for a few services that are running the cloud, maybe a couple of thousand, but when we're talking about tens of thousands of services, there's a scalability challenge. So we need to address that. The second is just still not, although we can audit and trace from parameter repository, we're not going through an official change management process. So a lot of customers I've worked with, organizations, they've always said that unless we could trace this somehow through our change management process and we can control this, there's no way we can go out and implement this thing at scale because it'll just be too difficult to trace. We need to somehow address these two challenges. So to do that, we embed the last components of continuous optimization. And the last components here, namely being, I've actually worked with a customer that did something like this, where they've gone ahead and they built a solution to actually automatically analyze, so to avoid the manual analysis. So you need to have some kind of optimization engine that can audit the resource utilization, analyze it, and generate new answers for your infrastructure spec. And they've done this, and they actually wrote it back to the tags on those services. That's one way of doing it. But this optimization engine, doing this is just only the first step of the process. The second step is, as we said before, there needs to be some type of change management integration. So the service has to go out and say, hey, I'm going to invoke and interact with your change management process to communicate with the appropriate stakeholders to acquire the necessary approvals for me to go ahead and implement this change. And only then do we go out and say, hey, let me deliver these recommendations to that parameter repository such that the next time they input some new code to the pipeline, I'm going to pick up those changes. Okay? Now, I know that it is a very simple example. Some may even say it's an oversimplification of a DevOps pipeline, and that's fair. I just wanted to write down the components that are specific for what we're talking about here in today's webinar. So I know that there are, these pipelines can be, overly complex. There's many different types of tools, there's different ecosystems, and that's completely fair. So what I'm doing what I'm going to be doing over the next few weeks is releasing very detailed workflow diagrams of how you can implement continuous cost optimization into different ecosystems, from IaaS all the way down to containerized environments. You can find them over on our dev site, and that link will be provided towards the end as well. I'm not going to go through this, go through all of these go through the processes that you're seeing here on the screen. We just don't have the time for it, but you can review this separately. Okay. Now, we're going to jump over into the demo, and before we jump into the demo, let me just take a look at the time. Okay. Before we jump to the demo, I just want to give a quick alignment of what you're actually going to see, so you can actually follow along when I'm jumping through different consoles. There's many different elements that are integrated in together. So just for some context, what are we going to see? So we have a developer here, that could be me. We're going to go ahead and use GitHub as our source repository, and we're going to upload some new source code to that GitHub repo. And that's going to trigger a pipeline that's implemented inside AWS. We use AWS code pipeline. It's a 3-stage simple pipeline. There's actually no build process. It's going to go through code commit. It's then going to go through a deployment phase where we execute infrastructure deployment. That's going to automatically, as you would guess, trigger CloudFormation to go ahead and deploy some infrastructure inside that public cloud environment. There's 2 EC2 instances that will deploy. Now, once that deployment is complete, we're going to go out and execute the 3rd stage of the pipeline, which is an application deploy. It's going to go out and deploy that application onto that specific infrastructure. It's a very simple hello world application. It's a static website, and we're going to be able to log in and say, hey, this is the actual page, so we know what it is. Now, this infrastructure has already been deployed, and we're going to start this is where we're going to start from. The very first test we're going to provide, or we're going to perform, is just push a standard app update using this pipeline. So we'll just change the body of the website, and when we do that, we'll actually see this website actually change. You guys already know, I'm sure a lot of you guys have seen this kind of demo. What's interesting here is what I want to point out here is that infrastructure not being modified in any application push, in any new iterative code push. Okay, so we integrated CloudFormation, we integrated the 2 pipelines together, and there's no change to the infrastructure as we deploy new versions of the code. Okay, the 2nd stage, we want to get some insights out of this environment. So this is where we connect Densify and ServiceNow. So Densify would be connected, we would analyze, and we would deliver these insights. We create recommendations inside parameter repo, which is integrated now into CloudFormation. We create tickets inside ServiceNow. I know it's slightly different from what I've already shared, but this architecture also works quite cleanly. Now, as a developer, we're going to be able to log into ServiceNow to actually view those recommendations directly in real time. Now, for this particular chapter,
Dinesh, you would say that at that phase, the developer is at least educated as to what the analytics is saying should be optimal, correct?
Absolutely, absolutely. But at this stage, it's very clear. It's important to understand that we're not providing any approvals. So now we still continue to execute our pipeline. It's still business as usual. We're uploading another iteration of code. So we'll just modify it to test run 2. We run it, and we notice that the infrastructure has not been modified, but the application has been modified. So just business as usual. Now, in the 3rd stage, we're going to come in and say, hey, let's go back to that ServiceNow and actually provide an approval. So we approve the recommendations for the 2 instances running in that environment. We'll observe ServiceNow going out and change the states inside the parameter repository. And then on our next iteration of code release, we'll notice at the bottom there, it's no longer a C5 and an M4. Instead, the infrastructure is modified or updated according to the approvals, according to what's been approved. And we also notice that the website gets updated to the 3rd run. Okay, so this is the scope of the demo, and I'm going to go ahead and run it now. And I also want to mention, it's a pre-recorded demo. The reason why is we're going to go through a lot of infrastructure changes here, and that can take time, minutes. And I don't have 15, 20 minutes sitting there to watch the infrastructure spin and modify itself. So we're just going to we pre-recorded and extracted the value that you guys need to see. So let's go ahead and run it. So I'm going to start here in GitHub. We'll run through the sandbox before we actually execute those tests that I just mentioned. And in the sandbox, so this is a simple application, as I mentioned already. It's a static web page. It's actually a hello world from the code pipeline library that I pulled off of AWS. But you have a couple of files here. There's a stack.yaml file here, and this is the CloudFormation template that's going to spin up the infrastructure. we have an index.html file. This is nothing more than just a simple static web page. And we have two other files here. This is specifically used by code deploy to map these onto the target server. And we're going to use a Windows server and use the IIS service of Windows to actually host this particular website. Now, to actually update this GitHub repo, we're going to do it exactly how an engineer would, which is use some type of Git tool, or Git. In this case, we're going to use Git for Windows to actually update this repository. So I'll just use a tool like this, and there'll be more on this as we go ahead and execute. Okay, so let's move on to the next part of the sandbox, which is the actual pipeline. As I mentioned before, it's a very simple pipeline, 3 stages. There's no build process here. We have a source stage implemented using code commit. This will be triggered whenever there's a change to GitHub, and that automatic trigger, once it's registered in the latest files, it will trigger the 2 deployment stages. First, the infrastructure deployment, as you see over here, which will invoke CloudFormation. I'll show you guys that in a moment. And also, it'll go down to the code deployment stage and deploy that or execute that specific stage, 3rd stage of that pipeline, to get those applications on that target instance. Okay, so on the CloudFormation screen here, I've already mentioned this infrastructure has already been deployed. So it's deployed as simple stack that you can see here, and this CloudFormation is already integrated back in that stack. If we look at the resources that it implements, it's a very simple demo. So there's only 2 EC2 instances there that we specified. One is going to host a website, and the other one is just another database instance there, just so that we can see a second example of this being executed. And over on the EC2 console page, we can actually see the 2 instances that are up and running as an M4 and C5. And on the website, if I just refresh the site, this is running on that specific web server. So the Hello World website is up. I'm just calling it demo page, and as we update the body, we'll see those updates. Okay, jumping back to the code pipeline. So we're back in the DevOps pipeline, and we're going to perform the very first stage, which is I'm just going to push a standard web update, right? I'm going to push an update to that site. I'm going to use Git to do that. So this has no Densify, there's no service now, there's no complicated. This is the expected behavior here is I should see the change to the update without any changes to the infrastructure. Update to the app without any changes to the infrastructure. So I'm just going to go ahead and update this, and we're just going to change the body of the index file here just to reflect some new information so we can see that update running through. So call it test run 1. I'm going to go ahead and commit some of this. And a lot of you will be familiar with this process if you're using Git to manage your source repository. So I'm going to push that change over to GitHub, and that push is going to trigger a change here in the DevOps pipeline. So if I refresh the page, okay, so you can already see it already executed through. So source and deploy is already executed, and it's gone into the 3rd stage, which is deploying the application. So it looks like the application, it succeeded, the 3rd section of it. So we're going to go and check the different components. We go over to CloudFormation, hit over to the Events tab. We'll notice there's been no change. Head over to the instances. If I refresh this page, I'll notice that there's no modifications here to the EC2 instances, still running at C5 and M4, which is the expected behavior. If I head over to the demo and then I refresh, I can see that the app has been modified. So the body of the site is now reading test run, which is the expected behavior, right? We got a simple pipeline, simple hello world pipeline, it's updated the app. So now let's talk about Densify and Service. Now we integrate these 2 elements back into the environment. So Densify has analyzed that specific environment. We've identified the 2 EC2 instances, and we've generated a bunch of recommendations. We recognize them as a C5 and an M4, and we're recommending jumping across over to an M5 and an R5A respectively. At the bottom here, you'll notice different workload curves. So this is some of the value that we provide. We're analyzing those underlying workload statistics or the performance metrics to determine what are optimal sizing. So not just current utilization, but also what the utilization look like on what we're recommending, which a lot of our customers have said is key value. So from cost impact to effort impact to even hardware specifications, we provide all of this empirical evidence in the console. But more importantly, we also provide it in the ITSM platform, which again, now we're talking about the component where we're integrating back into that ITSM layer for that change management. So this is the change management screen that you're seeing. And we're just waiting for those tickets to be created. So you can see the tickets have been created for those 2 insights here in the change in the ServiceNow console. If we just go into one of the tickets, I just want to show you guys what it looks like. Right now, this is the default out-of-the-box population of the ticket. All of the context is written right into the description field. And the intent is a lot of our customers write business rules to repopulate this ticket according to their own internal processes. We also attach a PDF file to the ticket, which is a Densify PDF file designed for that application owner or that engineer to review all of the empirical evidence behind what we're saying is the actual appropriate sizing spec for this specific instance, from effort and cost and so on. Now, we're not going to approve anything. Instead, we're going to go to the other component within our pipeline, which is now the parameter repository. And we're going to implement that using AWS Parameter Store. We've implemented it using AWS Parameter Store. You could find it within the System Manager suite of tools within AWS. So just search for System Manager under Services, and you should find it. And this is implemented, the 2 different parameters have been created here to hold the instance type field for each of the 2 EC2 instances. So for the web server, you'll notice that the value here is written as C59 extra large. So although we've synchronized the recommendation to the parameter repo, the value is of the current instance type. It's not of what we've recommended, but rather what we're initializing it to. So you could track that in historical changes. Any changes that we make to this instance type will be reported there. And also the complete context details behind the recommendation itself, which you similarly saw in the description field in ServiceNow, is also populated as part of the tags for auditing purposes. If you wanted to create a quick script or a BI tool to actually go in and audit any of this, it's very simple to do. Okay, so we go back to the DevOps pipeline and we say, okay, great. We have Densify in there, we have ServiceNow in there. Let's go ahead and push another app update, right? It's just business as usual. We don't want to see any infrastructure change. Although we're in the mix now, we're in the pipeline, everything is integrated, answers are being produced. We want it to be business as usual. We don't want any changes to our infrastructure. So I'm going to go ahead and I'm going to modify this to test run 2. And I'm going to go ahead and just commit this new piece of code back to GitHub. Okay, we'll just put a label here, call it test run 2. Just git push origin master. Okay, now that it's pushed across, we'll wait for the pipeline to be triggered. If I just refresh, it's running through. We can see that the source stage now has been triggered. It's pretty quick. It's a webhook trigger. The second stage is now running. You see CloudFormation. It's returning as successful. And the third and final stage is run as well. So you notice over in the CloudFormation screen, there's been no changes here. CloudFormation, although executed, did nothing. If we go to instances and I just refresh the screen, I notice again, there's no changes, which is what we want. It's the expected behavior. Now, if we actually go back and say, okay, is there actually a modification here on the website itself? So I'm just going to refresh the actual website. And you can see now it says test run 2. So the code change that we wanted to implement has been executed on the instances without changing any of the infrastructure settings for that for the services hosting this application, which is what we want. Now, for the final step, we're just going to go into ServiceNow and we're going to approve that ticket that we saw. So I'm just going to go ahead, hit approve, and we're going to hit approve here. And now that recommendation, I've done this for both of the instances itself. So both recommendations are now approved. And we want to see what the changes are like. So if we go to parameter repository, we said that as soon as we approve inside ServiceNow, we want that system to go out and approve the necessary elements within the parameter repository, such that on the next iteration of execution, we should see an update to that infrastructure. So if I go over to the web server, we notice the value. The value is no longer C59. Instead, it's been updated to something different. It's an M5A, which is what Densify was recommending. The history actually tracks those changes. So this is all auditable within parameter repo. We go back to parameter store. I'm actually going to jump back over to the DevOps pipeline, and we're going to perform this test again. So we're back in the DevOps pipeline, and let's do the last and final test here, which is, again, the developer here is not focused on infrastructure optimization. They're focused on just updating their application, delivering value to their customers. They're going ahead and updating their application. That's it. So we're just going to open up our index file and now modify it from test run 2 to test run 3. And I'm going to run this again and observe the behavior. hopefully if all goes well, then we'll see an update to that. Well, it will go well, but we'll see an update to the infrastructure. Okay, so we run this again, and we push this change back to GitHub. Okay, and I'm just going to refresh again on code pipeline. Okay, the source stage is executed. We'll refresh this guy again. And we notice here the second stage is now in progress. So if you actually go to CloudFormation, you can actually see there's an update in process to the actual EC2 instance that's actually hosting this our application. So I just refreshed the EC2 console here, and we notice that the EC2 instances have actually been updated now. So no longer C5 and M4, it's an R5A and an M5A, which is the expected behavior. We wait for that CloudFormation to complete before we can go into the application deployment step. So let's go back to the pipeline, and I'm just going to wait for the second stage to complete. And once that's completed, then AWS will go into the application deployment step, and we'll see whether the application is deployed correctly onto that target infrastructure. Okay, so let's just wait for this to roll. And it's still running here at the bottom, so it's going to complete very shortly. And this is the kind of rolling I wanted to avoid in an actual live session. It would take much longer than this to actually execute. So there you go. So you have the application actually deployed using code deploy. So we're actually going to open up that site to see if the change that we requested has actually been pushed. So you can see it's now showing test run 3. So the purpose of this demo was to show that how we could very quickly and simply integrate continuous optimization into an existing DevOps pipeline by merging both the infrastructure deployment pipeline with the existing DevOps pipeline.
And you've achieved two key things here, Dinesh. You've taken the hassle off of developers to think about resourcing, and you've set the organization up to, sorry, just Pega making you presenter here for your component. You've set the organization up to benefit from continuous optimization of whatever that entity is over time. Those are the two big takeaways there, I think, from that very slick demo.
And that would be the end of my demo. I did want to show specifically how that was actually functioning under the hood. I know there's a lot of engineers that may be saying, okay, but how did CloudFormation know to go ahead and update that infrastructure at that point in time on the third run when you provided the approval? There's a lot of context that you can find on our dev site. I wish I had a little bit more time to get into that level of depth. But for now, we'll jump over to our next section, which is Pega. And Pega is part of our services team, and she's going to be going through some practical examples of this type of implementation in live customer environments. That'll be exciting. Over to you, Pega.
Thank you. Can you guys see my screen?
Yep, we're good.
Okay, great. Well, hi, everyone. My name is Pega Garusi, and I'm one of the solution architects here at Densify. In general, customers have started to adopt DevOps automation pipelines as they've realized the benefits that can be achieved by following the DevOps philosophy. And we see these customers use a variety of different tools to achieve this. Densify's responsibility here is around producing the recommendations to optimize the things that are being deployed into the infrastructure. Today, as mentioned by Dinesh, I wanted to go over a few customer examples who have implemented the continuous optimization process using Densify. So the first customer that I have here, which I'm able to share the name with you, is Raiffeisen Bank. For those of you not familiar with Raiffeisen, they are a large bank with multiple affiliate banks spread across Europe. They have been a customer of Densify for over 2.5 years. They have a rapidly growing container ecosystem and are leveraging Jenkins to automate their CI/CD pipeline. Their platform consists of OpenShift, PostgreSQL, and Kafka clusters. All their new applications are microservices-based applications using container orchestration technology. As you may know, with containers being so dynamic, even just getting a basic inventory can sometimes be a challenge. There are many interdependent moving parts to manage cohesively, and low-level utilization charts don't always give the big picture. Densify allows deep visibility into containers, nodes, utilization patterns, and costs incurred by the line of business, and accurately provides optimization recommendations for the container and pod resource allocations. Raiffeisen found out very quickly that leaving the resource configurations up to their developers led to frequent resource expansions and even some instabilities caused by memory shortages. And this is really common in the industry. I alone have spoken to 3 other customers in the past 6 months who are facing the same challenges, and they're actively seeking help to solve it. Looking at their pipeline, they needed to quickly stand up a couple of environments, including Dev, Sit, UAT, and Prod. So they've set up a CI/CD pipeline, including Git, Jenkins, Docker, and Kubernetes, to build microservices-based applications using container orchestration technology. They are using Red Hat OpenShift, which by default provides support for Docker builds, as well as many others, to quickly produce runnable images from their image repository. They decided to complement their CI/CD pipeline by adding DENSIFY so that container resource configurations are automatically set by DENSIFY'S recommendations. And I'll show you guys in a bit how they've achieved this. But first, I wanted to kind of concentrate on DENSIFY and what kind of recommendations you'll be able to see when using DENSIFY'S UI. Here's a screenshot of the DENSIFY UI. Each row on this screen represents a container that's been observed running in the environment. We collect data regularly using Prometheus, we analyze it, and provide recommendations. What you're looking at here are the recommendations for each container, including details regarding the cluster it is running on, the namespace it belongs to, the controller type, the pod name, and container name. We also define in this column what kind of recommendation is being suggested here, such as is it an upsize or downsize, etc. From the top of the UI, you have the ability to further filter your list to only look at containers specific to an application, a cluster, namespace, and many more. Once you select a container on this list, you then get to review the utilization patterns observed for that container at the bottom of the UI. If we take a look at the utilization pattern for this specific container, we can see that the CPU utilization for this container on average is running about 1,258 millicores. But between 12 and 3 o'clock in the afternoon, it is going beyond the defined CPU limit, which is set to 4,000 millicores, which is the same as the CPU request at 4,000 millicores. On the right-hand side, you'll be able to see the same utilization pattern, but this time with the recommended settings from DENSIFY. So we can see that by increasing the CPU limit from 4,000 to 5,370 millicores, you're actually allowing this peak to occur within its limit. And by decreasing the CPU request to 3,240 millicores, you're actually running your sustained activity a lot more efficiently. So these charts are here in order to provide the app owners the comfort level that they need in order to apply these recommendations. Within the body of the UI, you'll get a full list of the current and recommended CPU and memory requests and limits for all the containers. At the top, you get a summary of the number of containers that you have filtered in this UI, as well as the surplus that you can achieve for the CPU and memory requests by applying the recommendations from DENSIFY. You can also see that at times developers don't even specify the request and limit when spinning up these containers. And this is really noticeable wherever you're seeing a dash on the current columns. This puts the hosting nodes at risk, as a single container can take resources from an entire node. So it is really important to pay close attention to these recommendations. As mentioned earlier, Raiffeisen has built this pipeline where they inject DENSIFY'S recommendations as part of the build process. On the left-hand side of the chart, this is where the developer is actually writing business functions. They're writing codes. They have no interest in infrastructure at that point, and they're just writing application code to serve some business needs. And that's usually where the developer is being asked to size something that will be deployed. If the developer is defining the size of the container, that's where they'll be doing it. As you go through the next part of the chart, That's where the standard CI/CD tooling is doing its unit testing, packaging, to get itself to a point that they have a standard image that can be housed in an image repository, in this case into Docker registry. Once that image is in Docker and it's registered, it can then be referenced by other pipelines to be deployed into SIT, UAT, and prod. Now, throughout those processes, there are additional manual steps that this customer needs to go through, but some customers choose to automate and some don't. The important thing from DENSIFY'S point of view is that when you go to build that image, before it gets registered into Docker, you're actually baking in the optimal size of that image so that when it gets deployed, it is not wasting any resources and it's getting exactly what it needs. After introducing this change, Raiffeisen noticed a huge reduction in their resource demands, and frequency of expanding cluster resources were almost reduced by half.
Big impact.
Yes, absolutely. The second customer case study that I have, this is from a large insurance company. I apologize in advance, I'm not able to share the name with you. But they have a very large AWS environment, and they have established a CI/CD pipeline with Bamboo, Bitbucket, and CloudFormation. Their main challenges are just like many other companies. Their developers often leverage tribal knowledge to size their instances. So most of the time, we see them provision instances that are larger than they should be, and this increases cost, and sometimes smaller than they should, which introduces risk. Picking the wrong instance family is also very common. And these incorrect requirements become hard-coded through declarative infrastructure as code. And even if you change the instance type on the fly, the instance will be reverted back to its original misconfiguration after every restart. The second challenge was the lack of visibility into optimization potential. They really wanted us to make it as easy as possible for their app owners to have access to these recommendations via their day-to-day tools. They also found that application owners hardly take the time to manually update their templates with optimized configuration, which results in continued waste and over-provision instances. So we've taken a look at their original design to see how this could be improved. Their developers typically log into a cloud portal in order to put a request for a new application. At that point, they'll be provided with a Bamboo pipeline, and they use a CloudFormation template in order to define the resources that they need for their application. And the pipeline will go ahead and trigger and create a stack in AWS. They found out that their developers tend to not go and update their CloudFormation templates much unless they're adding or removing resources from their stack. So they don't really do much of an optimization of their existing running resources. So the way we've solutioned this is that we've added DENSIFY to go ahead and collect utilization and billing data from their AWS environment. We then analyze and provide recommendations for their running instances, including EC2s, RDS, and ASGs. From there, as mentioned earlier, one of their challenges was the visibility into these recommendations. They didn't want DENSIFY to be a third-party tool that people would have to log into in order to have visibility into these optimizations. So to make it as easy as possible, we wanted to extract these recommendations from DENSIFY to make it available into their existing tool. So from there, we are delivering these recommendations into a centralized repository of their choice, which was AWS DynamoDB. From there, the developers still continue to log into their cloud portal as they always do, but now we're able to surface the recommendations from DENSIFY as Cloud Portal will be referencing the DynamoDB. The developers get to review and approve these recommendations, and the approvals will also get written back into the DynamoDB. So this DynamoDB is really working as a centralized repository, not only containing the recommendations from DENSIFY, but also the approvals.
So that's an example like Dinesh was showing of a parameter repository, but their own flavor.
Absolutely.
This is an AWS example. If you're talking about Azure, you could use Key Vault, GCP. They have their own. So it's a common principle behind leveraging any type of infrastructure as code.
Correct. Now from there, in order to minimize the amount of manual effort required so that app owners don't have to go back and manually update their CloudFormation templates, they decided to add a custom resource within the CloudFormation template to do a reference lookup from DynamoDB. So these custom resources, they're, as Dinesh mentioned earlier, they enable you to write custom provisioning logic inside your CloudFormation template to run anytime you create or update or delete your stacks. Custom resources require the service token, which specifies where CloudFormation should send the request to. So this could be anything such as SNS topic, Lambda, to go and do the reference lookup from the source system, in this case, DynamoDB. So this custom resource will take a look at the recommendations, and if the recommendation has been approved, it will then return the recommended instance type. And if there's no approval in place, it will simply return the current instance type. In that case, the pipeline will detect the change and CloudFormation will go ahead and update the stack. Now, for this particular customer, they wanted to do all their approvals within their cloud portal. But we've worked with many other customers that wanted us to integrate into the ITSM tool of their choice. So we've done many integrations with ServiceNow, Remedy, Jira, etc. We've also worked with many other customers using platform agnostic tools such as Terraform and Ansible. Based on the different tools and the pipelines and the way you do your day-to-day business, the design could slightly vary, but the concept really remains the same. I hope that these two examples have given you guys a good idea of how you could achieve continuous optimization within your organization. And I will pass it back to you, Chuck.
Thank you, Pega, very much for making it all very real. It's always great to see real life examples. We're right at the end of our time slot. We ran a little longer, which is fine, probably because the marketing guy talked too much. You guys can see my slide?
Yes.
Okay. To not keep people too much past the hour, just very quickly, Densify trials, easy, fast, CI/CD poster that Dinesh mentioned, available for download on our website. Raiffeisen, the video in their own words, the story that Pega was telling. You can hear that from a video up on densify.com. Welcome the opportunity to download that. But my slide keeps changing because it's on an auto roll. The prizes marketing team has selected randomly during our session. Hopefully these folks are still there. The gift card, $100 Visa gift card winner is Jeff K. Jeff K, we will reach out to you. And the grand prize, the Nintendo Christmas Switch, Holiday Switch, I should call it. The winner is Mark M. Mark M. So congratulations, guys. Thanks for attending. Hopefully you found this very interesting. If you had questions that you didn't get answered through the console, there are some, we will reach out to you. But also answers@densify.com is a great way to reach to us. Pega and Dinesh, thank you very, very much for your content today. It was wonderful. And everyone else, have a wonderful holiday season. Safe and wonderful holiday season. Thank you all.
Thank you, guys.
Bye.